Hello guys, welcome to another video. This is a continuation of UIViewRepresentable. I made the first part last week, so if you haven't seen that video, I will leave you the link in the description and also a tag here. Let's see today a more complex example and also describe other two concepts really important, coordinators and context. So let's get started. My name is Pete and this is SwiftUI Tips.
Okay, now let's create something funnier here. We have here a custom text field that represents some kind of pin code. If we just type here, we now see that we can just type numbers, and the thing is just creating a kind of representation of all the pin codes we can type. In this case, we have a maximum of 6, and also we have just a space between each number. Okay, we can create this in SwiftUI. However, it's actually simpler to do it in UIKit with UIViewRepresentable. So let's find out how we could create that. Okay, let's see first what we have in our starter project. Remember that I always put in the description the final version of this code, but if you want to follow me building this code, it's great too. Let's check first the content view. That is actually a LoginBankView, so let me rename here this. Let's actually run the preview here. Okay, cool. We have only a background grading view that we use in previous videos and a back title, but let's explore this. Yeah, we have something really simple here. It's just gradients of colors. And we have a H stack with an image and a text. Okay. I also have a MainBankView, but you can use whatever you want. Okay, enough talk. Let's actually create our PinCodeField. To do that, well, let's create a new file. And again, let's use UIViewRepresentable and UIKit. Okay, one more time, we require a UI type view, but in this case we will use UITextField. Let's fix this issue. There you go. Now we don't need this type alias anymore, so let's remove it. Okay, it's time to initialize our UITextField. Okay, let's run this in our SwiftUI view. Let's go back here and put our value, I think, below. And that's right. Okay, you may start noticing something here. We have a giant text field here. This is because by default, SwiftUI will take care of the actual rendering here. So it will take the appropriate value according to the space. But if we want to force a specific frame, well, we need to do it explicitly. So let's add a frame here. Let's use whatever type you want. I will use a width of 300 and a height of 60. There we go. Okay, we cannot see anything, but yeah, it's working. However, we can type, well, this is not looking as the previous example, so let's just fix it. First, we need to change the color of the font, so let's use a white color. Also, let's modify the font. Let's use a large font here. So I will use a default font, but with a large title font. Okay, let's run this. Okay, looks better, but still we need to change this keyboard. So let's reflect that change first. Instead of using the default keyword, we'll use a number pad keyword. Okay, it's better. But now, how are we going to add this space between the numbers? We need to use something called text attributes. If you remember in UIKit, there is, besides of regular strings, we have something called attributed strings. So it's basically, well, custom strings that you can modify character by character. It's something that we need to update. So to do that, we will update a value from default text attribute in the text field to specify what is the spacing between each letter. For that, we use a key in a dictionary of properties that text field contains using a kern value. Kern key, I mean. And here we will add the spacing value. For that, let's add something here specific for the value, for the spacing. And I propose a 20 value. Yeah, you can use whatever you want, but 20 is fine for me. And like I mentioned before, we need to use a specific key here. So in this case, we want to use kerning. Additionally, this text field requires a placeholder, to reflect the underscore values. Let's add that, but also we require those placeholders contain the same spacing, so we will use a property called attributed placeholder. Here we will use something well known as ns attributed string. And here we will use this particular initializer, the string here, because we want to just restrict 6 values for this particular text field. Okay, it's just typing 6 underscore. 1, 2, 3, 4, 5, 6. There you go. And for attributes, we need these 2 attributes, one for the spacing and other one for the color. Remember to use here UI colors because we are working with UIKit. Yeah, colors from SwiftUI are different from UI colors. There you go. Let's try again. Okay, it's looking good, but we have a kind of misalignment here. Let's fix that. Okay, what I propose here is actually reducing the width of 300 to 235 and using a padding for the leading part because, well, it's properly aligned to the center, but since that we don't want to center this text because otherwise we will lose, the representation of the pin code here, we actually prefer just to, reduce the space here and put some space there. To do that, let's add padding to the leading side of 30. There you go. I mean, you can play with these numbers and make other variations, but yeah, it's just to speed things up. Let's try again. Okay, it's looking good. However, we can still add even more. Well, I'm adding numbers because I'm using the keyboard from my computer, but we also need to validate that we cannot add more than 6 numbers here. How we would do that? Okay, at this point, we don't require yet the update UIView. Remember, this is specifically if you want to do any action once the UIView is rendered again. But for now, we don't care, but let's just put a print statement here just to identify when the view is rendered. Okay, back to our problem. How are we gonna restrict the user to just type at maximum of 6 numbers? It's easy by using UITextFieldDelegate. However, who should be that object that will delegate that work? Well, it can be PinCodeField because remember, it's a struct and every time SwiftUI needs to render a view again, PinCodeField will be destroyed. So this should be something else, right? Yeah, actually, if we go back again to UIViewRepresentable, we have here something called coordinator. A coordinator is basically an object that we communicate changes with your SwiftUI interface, like you can see here. The thing is that this object is managed internally by SwiftUI, and we can use it as a delegate object that will handle all the scenarios for our changes in UIKit. So this is great. And also, we have a context here. If we go back to our methods, yeah, context is a kind of object that handles all the states related to our UIViewRepresentable. And one of those states is a coordinator. Actually, by default, it's provided a coordinator, but in the example earlier, we don't require it. You can override a specific coordinator depending on your requirements. So let's use that. But let's create an extension just to keep this piece of code more readable. Okay, the first thing we need to do is actually create a nested class called coordinator. Let's inherit from NSObject and conforms to UITextFieldDelegate. Now, one of the requirements for coordinator is providing us access to PinCodeField, right? Because coordinator will survive after a rendering in your view, but we require to understand who is then the SwiftUI view here. For that, let's then create a property that could provide us what is the current view showed at this point. We can call this as a reference because it's not a reference, because it's a value type, but we can understand that every time we receive a new update, we will actually handle a new PinCodeField. So one common pattern here is called this parent, because yeah, this is actually the source of truth in some way to refer to our SwiftUI view. So let's refer this to PinCode, because remember again, this will provide us access to the current state of our view and create an initializer. Create this initializer with our parent property. In this case again is PinCodeField. And now, as another requirement for PinCodeField, let's actually create a new method here called makeCoordinator. MakeCoordinator will override the previous coordinator. Well, basically it's a void value, so we don't care, is what we're saying. But in this case, yeah, we care about the coordinator, so we will initialize this with a coordinator value. And we will pass self, making the reference that we are talking about PinCodeField here. Okay, that's it. That's the only requirement that we need to establish a new coordinator here. Okay, now we happen with our validation for 6 numbers. First, let's add a value here just to handle the actual limitation, max length, but without having magic numbers around our code. And to check number by number, we need a delegate called should change characters in. Oh, long name from UIKit delegates, right? What's this one? This is the value that we want. We want the one with range and with string. Okay, now to get the actual text in the text field, we need to extract them from textfield.view. Since that is a nullable value, we will use a guardlet value. And we will return true. Remember, this value return true is telling the text field that name mentioned here, we will render a new character type in the text field. Otherwise, if we set to false, no matter how many types we do, we won't see any update. But this is specifically for UIKit, remember. Now we need to do the actual validation here. What we'll do here? Okay, we already have the current text. Actually, let's rename this to current text. And let's handle other 2 values. One to get the actual strings added to the text field, and other to reflect how many characters were removed from the text field. Yeah, because remember, this method is called when you add or remove any character into text field. So to do that, let's get first the added strings. To do that, we need to use a string.count. Yeah, is the counting that we want. And also to get the removed values, we need to get the range that is provided in the parameter. Yeah, for this particular case, and for you to understand my logic, range.length will give us the number of removed strings if it's the case. Okay, now that we have those three values, the thing to identify the new length of our string is the current text that count plus the new added strings minus the remove strings. There you go. Now new length will give us the future value for the text field. So just we need to validate if we are in the range or not. To do that, what we need to do is return new length and compare if it's less or equal to max length. That's it. Now let's try again. Let's use 111, 444, and then add a number 5. Okay. It's still not working. Do you know why? I will give you just a few seconds if you want to pause the video just to identify what is the problem here. We have this delegate method, with the validation. And we have, we just a method to make our UI. We don't have nothing here, so the problem should be here. Pause the video a few seconds and understand what's going on.
2 hours later.
Okay, are you ready? Yeah, it's a classic. I forgot to set specifically that my coordinator is a delegate. Okay, let's move back here and establish what is the object that will handle all my delegate methods. For that, we will require to use the context because context is handling the coordinator object. So it's just simple that TextField.Delegate equal to context dot coordinator. There are more that we will explore later, but for now, coordinator is a thing that we care. So let's try again. 111, 444. There you go. Look at this. I'm still typing and we cannot see more numbers. This is great. Okay, we're so close to finish. Now what we need to do is once we end the 6th number, we want to dismiss the keyword and then make the user open the balance account, but obviously we need to make sure that we type the PIN code correctly. But okay, let's do one more piece here. Okay, to dismiss the keyword, we need to make sure what is exactly the condition to do that. So the condition is that if we reach the max length, then hide the keyword, okay? Before sending this return value, the only thing we have to do here is check if we reach that. So if new length is equal to max length, in this particular case, the only thing to do is resign range responder. There we go. Let's try. However, we have a little issue here because at this point, this delegate is not ending the typing, right? This is in the middle of the process. If we just hide the text field immediately, we then won't reflect the latest changes. To do that, the only and simple thing for now is just updating the text field manually. So to do that is just textfield.text with the new string. That's it. Now, in this particular case, we will update to the latest changes, but also we will hide the keyword. Excellent. Yeah, it's working. We can use again. We cannot add more values, but we can hide it. I mean, we can erase a couple of things here and we can start over. Pretty nice, it's cool. So now we need to inform to SwiftUI that we want to display another thing when we type the correct pin code. So to do that, we need two conditions. One is identifying when we've just finished the typing, and this is really simple. We need just to use did end editing. Once we dismiss the keyword or call this value here, we then will call this one because our editing is finished. But in order to communicate to SwiftUI that something has changed, we need then to expose a binary object because the SwiftUI view will handle the state. Let's add here then a binary object reflecting the state of the text. And the only thing we need to do is then use our parent view, that is actually our pin code, and use the text that we just created and update that text with the current text located in UITextField. Since that this is optional, we need to use a default value. Okay, we are good to go. Now let's go back to SwiftUI. Okay, now here we need to create a state property. And we need to add the missing parameter. Now we need to render a full screen view once we finish the validation of the text. So to do that, we need to add another state property to reflect that we need to move to the next screen or not. And add a sheet modifier here to render the correct view when we actually got that success. And now we need to actually catch, well, what will happen with text, okay? Because at this point, we cannot do anything with text. What we need to do is validate if we got the valid code. We need to call a new modifier introduced in SwiftUI 2.0 called onChange. That we require to observe any particular text field, in this case text, and we perform an action. In this case, what we want to do is checking if the validation is correct and then reflect a new change. Let's actually change this to value is true only. The new value is equal to 111222. Let's run this again. Excellent! We got finally access to the main application. But before ending, normally I don't like to put business logic here because this is something that is not testable and we will talk later about testing. But just to keep things clear, let's create a view model to handle all the business logic here. It's a really quick change. We will use combine because we will use observable object, and we will create a class LoginBankView model. We will create a text that will be exposed as a published value. Also another published value for the flag to render the new screen. And also, just for speed things up, we will create a valid pin code internally here to set to 22344. This will be the validation, and we will add a method to actually validate the string. There we go. Now back here, instead of having this, let's remove this and create a state object. Let's just update this. Oh yeah, of course, we forgot the brackets. Excellent. One more time. If we type 1 or 4, it's not working, nothing happens. You can do whatever validation. It's up to you now to, complete this functionality. But let's add the actual valid code. 22, 33, and 44. Here you go. So in summary, if you're required to do something with UIKit, for example, you have a reusable component that you created before and you want to incorporate your SwiftUI, yeah, it's a good strategy to use UIViewRepresentables. Some people saw this like, oh, SwiftUI is incomplete, but in my opinion, it's a great and clever way to reuse code. Yeah, you don't have all the time to restart implementation something in SwiftUI because it's a new framework. Yeah, you can reuse your previous code, no matter if it's in UIKit or something else. Yeah, it's completely valid to bring legacy code to this new framework. So yeah, you're good to go. Also, remember the lifecycle here. When we initialize a new UIViewRepresentable, the first thing, this protocol, we will require a make coordinator. It will initialize this, but if you require anything, well, it will use a void element here to reflect an empty coordinator. And also, as you can see, you can create your coordinator to make any kind of delegation actions like this one, for example. You need to create your UI, you set up all the things you require, and this UI view will still be reusable as much as possible because it's a reference type. This particular struct code will be rendered over and over again. So remember, do not include this particular property making reference to UI view as a property of the PinCodeField because it will disappear. Now that you make the UI view, you will get access to any kind of interaction you want to do for every update. So as you can see here, we don't need to do anything, but at the end of the max length validation, we are just updating our text for SwiftUI. This is another important thing. You don't have to always be aligned with SwiftUI only in specific events like this case, for example. That will save you a lot of time consuming during your operations. And remember, we didn't use it here, but if you're required to clean up something, you can use dismantle UI view to, I don't know, maybe remove your notification center actions or any kind of favor property that requires to be cleaned up before destroying the objects.
That's it for this video. It's great to see this interaction between our UI views in SwiftUI through UIViewRepresentable. Yeah. However, what happened with view controllers? Yeah. Do we have anything for UI view controllers in this case? Actually, yes, but we will discuss that in the next video. For now, I would like to say thank you to everybody for your support because, yeah, you are great. Also, if you haven't done yet, please subscribe and leave a like if you love this video. And share it with all your folks because this is really important to know that we can incorporate all legacy code in SwiftUI. Also, don't forget to follow me on Twitter, Swift and Pips, and my personal account too. Thank you so much again and have a great day.